All right, so get ready because today we're taking a deep dive into how we actually get to Mars.
Hmm.
Yeah, and we're talking about these things called launch windows, those specific times when sending something, a
Yeah.
spacecraft up to the red planet just makes the most sense.
Yeah.
I've got some excerpts here from a couple articles, launch window and the basics.
Okay.
And let's see what we can figure out.
Well, it's interesting because launching to Mars isn't like, hopping on a flight across the country.
Yeah.
It's more like planning this really long and intricate sea voyage
Oh.
where you can only set sail when the tides and the currents are just right.
Oh, that's a great analogy.
Yeah.
So I guess what you're saying is we're not just waiting for Mars to be closest to us.
Right.
It's about like a bigger picture alignment.
Exactly. A launch window. It's not really about distance. It's more about using the most efficient route possible.
Okay.
So it's about when Earth and Mars are positioned in a way that we can use the least amount of fuel to get there.
Got it.
And that happens roughly every 26 months. Wow.
Which is where the orbital mechanics comes into play.
So less fuel means less money, right?
Right.
But what other implications are there when you're planning a mission?
Well, yeah, it's not just about saving money.
Yeah.
Using less fuel also means we can design simpler spacecraft,
Oh, okay.
and then we can pack them with more scientific instruments.
Oh, wow.
It's all about getting the most scientific return.
So more instruments,
Yeah.
but maybe a slightly longer trip then.
Yeah.
Is that where this Hohmann transfer orbit comes in?
You got it.
Okay.
The Hohmann transfer is like taking the scenic route
Okay.
instead of battling traffic.
Yeah.
It's the most fuel-efficient way to travel between planets.
Wow.
It uses this elliptical orbit that touches both Earth's and Mars's orbits. So launching within that window ensures that both the spacecraft and Mars kind of arrive at the same point in space at the same time.
I read that SpaceX is really interested in shorter travel times, though.
Yeah.
Are they just ignoring these launch windows?
Not really, no.
Well, so while the Hohmann transfer is the most efficient, it's not the only way to get there.
Okay.
We can actually shorten the trip to around 6 months by using a bit more energy.
Oh, wow.
And that's what SpaceX is aiming for. But it does require more powerful engines and therefore a slightly less massive payload.
So there's this real balance then between efficiency and speed and, how much we can send to Mars.
It's the challenge of mission design, for sure.
Right, trying to balance the ideal with what's actually possible.
Exactly.
What happens if you miss the launch window, though? Can you just wait like a couple weeks and try again?
Well, it's unfortunately not that simple.
Okay.
Missing a launch window is kind of a big deal.
Oh.
Think of it like trying to hit a moving target.
Okay.
But the platform that you're on is also rotating.
Oh.
So if you miss your shot, you have to wait for everything to line up again.
Wow.
Which could take years.
So even a few weeks could mean the difference between, successful Mars mission
Yeah.
and having to just put everything on hold for 2 more years.
Pretty much, yeah.
Wow.
Yeah, it underscores just how crucial precision and timing are in space exploration.
Yeah.
Every launch is a race against the clock. Not just to build the spacecraft, but also to launch it at that specific time.
So it's not just a technological feat to get a successful Mars mission. It's a scheduling feat, too.
Yeah, exactly.
Wow.
And it actually gets more complex when you think about it because you need a return window, too.
Oh, that's right. It's not like we can just turn around and come back anytime.
No.
Tell me more about that.
Yeah, so planning a return trip from Mars adds like a whole other layer of complexity,
Oh, really?
It's not as easy as just hitching a ride back on the next Hohmann transfer.
Also, we can't just pack up and hop on the return cosmic train whenever we want.
No, not quite. You have to remember Earth and Mars are always moving at different speeds.
Right.
That ideal alignment for, an efficient return journey might not happen for months after we land on Mars.
So astronauts might be stuck there for a while just waiting for the window to open up.
Right.
Sounds like a recipe for cabin fever.
Yeah, it's something we have to really consider.
Yeah.
We have to design missions that can actually sustain the crew for that extended stay on Mars.
Wow.
Enough supplies, resources, life support.
Yeah.
To keep everyone healthy and hopefully sane.
Yeah, I guess you can't just order pizza delivery to Mars.
No.
If you run out of snacks or something.
Right.
But that extended stay, it must really impact mission design in a big way.
Yeah, absolutely. It influences everything.
Oh, wow.
The spacecraft size, capabilities, types of experiments we can do.
Mm-hmm.
It's not just the physical challenges either.
Oh, right.
Think about the psychological impact
of
spending that much time away from Earth.
That's a whole other deep dive
Yeah.
we could get into.
Yeah.
But sticking with these launch windows for now,
Yeah.
I was wondering, how do they affect choosing a landing site on Mars? Does it matter where we want to touch down?
It absolutely does.
Oh, wow.
If a mission has to reach a specific location,
Right.
the launch window is going to narrow even further.
Wow, so we have to factor in not just Mars's position, but the location of the landing site relative to Earth
Yeah, exactly.
at the time of launch.
Right.
Okay, so it's not just about getting to Mars. It's about getting to a precise spot on a rotating planet,
Right.
millions of miles away.
Yeah.
Talk about hitting a moving target.
Yeah. And it gets even more complicated when we consider something called the phase angle.
Phase angle. I saw that term in one of the articles.
Yeah.
Didn't really quite grasp it.
Yeah.
What's the deal with that?
So the phase angle is basically the angle between Earth, Mars, and the Sun at launch.
Okay.
And it influences the shape of the spacecraft's trajectory
Okay.
and also how long the journey takes. So a smaller phase angle generally means a shorter trip, but it also requires more energy.
Oh, so it's like taking the scenic route versus the highway,
Thanks.
but with like a cosmic fuel bill to consider.
Right, exactly.
There's also another factor related to the spacecraft's orbit around Mars, right?
Yeah.
Something about its inclination.
Right.
You're really testing my space vocabulary here.
Okay.
What does inclination mean in this context?
So inclination refers to the angle of the spacecraft's orbit relative to Mars' equator.
Okay.
So imagine like a hula hoop around Mars.
Okay.
The inclination is how tilted that hoop is.
Got it.
Different missions need different inclinations depending on what they're trying to do.
So if you want to study the poles, you need a more steeply inclined orbit than if you're studying the equator.
Exactly.
Wow. And that plays a role in determining the launch window?
Yeah, just like the phase angle.
Okay.
It all boils down to orbital mechanics, you know, making sure the spacecraft arrives in the right place at the right time, the right orientation.
It's amazing how these like abstract concepts have such real-world implications for these missions.
Yeah, it highlights how everything's connected in space exploration. From the initial launch window to the spacecraft design.
The objectives.
Yeah, it all has to work together seamlessly.
Speaking of design, one thing that really stuck out in the basics was that SpaceX is aiming for those 6-month trips to Mars.
Yeah.
Why are they pushing for that shorter travel time?
Well, I mean, there are several reasons.
Okay.
First, it minimizes the risks to astronauts, you know, radiation exposure, other hazards of deep space travel.
Right.
And a faster trip also means less time for potential technical problems.
That makes sense.
Yeah.
But I'm guessing there are some trade-offs too, right?
Of course.
Like maybe we can't send as much equipment or do as many experiments.
You're right. A faster trajectory needs more powerful engines, more fuel,
Right.
which means less mass for scientific payloads.
It's another example of that balancing act.
Yeah.
Trying to find that sweet spot between efficiency and speed and what you want to do.
Exactly.
These Mars landings seem even more incredible now. Knowing how much planning and precision goes into it, it's mind-blowing.
It's a testament to human ingenuity and collaboration for sure.
Yeah.
But as we, keep pushing further into space,
Right.
these challenges are only going to get more complex.
So what happens if something goes wrong? Like you have a technical delay or something. You have to postpone.
Yeah, that's a critical question.
Yeah.
It really highlights how unforgiving these launch windows are.
Right.
A delay could mean missing the window entirely.
Wow.
And then you have to postpone for maybe 2 years.
So every launch really is a race against the clock.
Yeah.
Not just to build it, but to make sure everything's lined up with that window.
Precisely. It's what makes space exploration such a high-stakes endeavor.
Right.
But also what makes it so captivating that we can aim for these tiny windows in time and space.
Yeah.
And actually hit them.
I've also heard that these launch windows aren't like set in stone, though.
Yeah.
Is there any flexibility with those dates?
There is some, but it's limited. Okay.
I mean, obviously we can't change physics,
Right.
but we can adjust the trajectory a little
Okay.
by using more fuel.
Okay.
And that could give us a few extra weeks.
So a little wiggle room in the schedule.
Right. But it comes at a cost.
But it comes at a cost.
Exact.
So mission planners have to really think about that.
Yeah, they have to find the balance between flexibility and efficiency. All this talk about launch windows is making me curious about those dates you mentioned earlier.
Yeah.
Late 2026 and late 2028, early 2029.
Yeah.
What's so special about those times?
Well, those are the days when Earth and Mars will be in that sweet spot.
Okay.
For those Hohmann transfers, it's like they've synchronized their cosmic dance moves
Oh, wow.
to give us a chance to visit. But to understand why those dates work, we need to go a bit deeper into the science behind these launch windows.
All right, let's do it.
Okay.
All right, so let's break down the science behind these Mars launch windows then. We know that they happen roughly every 26 months, but what makes those specific dates in 2026 and 2028 so ideal?
Well, it all comes down to this orbital dance between Earth and Mars.
Okay.
So remember, Earth takes about 365 days to orbit the sun.
Yeah.
And Mars takes about 687 days.
Right.
So because of this difference in speed, Earth is essentially lapping Mars.
Oh, wow.
Every 26 months.
So we're on like the inside track, zooming past Mars every couple of years.
Yeah, that's a great way to think about it.
Okay.
And it's during this passing period that we get those launch windows.
Okay.
But it's not as simple as just waiting for Earth to overtake Mars.
Right.
The planets need to be a specific distance apart for that fuel-saving Hohmann transfer to work.
So we got to catch up to Mars at just the right distance?
Yeah.
Like making sure that the cosmic train doors are lined up perfectly?
Exactly.
At the platform?
And that's where the phase angle we talked about comes in. It's the angle between the Earth, Mars, and the Sun at the time of launch. And this angle influences the shape of the spacecraft's trajectory.
Right.
And ultimately determines how long the journey will take.
So the phase angle is like fine-tuning the launch.
Yeah.
To make sure we arrive at the right time.
Exactly.
Can you give me an example of how this actually works?
Sure. Imagine you're trying to throw a ball to someone on a moving carousel.
Right.
If you throw it when they're directly across from you, the ball has to travel a shorter distance.
Right.
But you got to throw it harder to make it reach them before they move.
Yeah.
That's like a launch with the small phase angle.
Right.
A shorter trip, but more energy.
Okay.
Now, if you wait till they're further along the carousel's path, you have more time.
Yeah.
But the ball has to travel a longer distance.
Right.
That's like a launch with a larger phase angle, longer trip, but less energy.
That's a great analogy.
Yeah.
That makes it a lot clearer.
Yeah.
So for those 2026 and 2028 launch windows mission planners, they've already figured out like the best phase angles. And
exactly. They've crunched the numbers to figure out the launch dates.
Wow.
To give us the most bang for our buck.
But you mentioned earlier that there are other factors too.
Right.
Like the inclination of the spacecraft's orbit around Mars.
Yeah.
How does that fit into all this?
So inclination, remember, refers to the angle of the spacecraft's orbit relative to Mars's equator.
Right, like that hula hoop.
Exactly.
Yeah.
So if we want to study the Martian poles, we need a more steeply inclined orbit than if we're focusing on the equator.
So it's not just about getting to Mars, it's about getting there at the right angle.
Exactly. You got to park your spaceship in the right spot.
All of this makes me wonder about the future of Mars exploration then. Knowing how these launch windows work.
Yeah.
How might they influence the design of spacecraft in the future?
That's a great question. Maybe we'll see more emphasis on technologies that can shorten travel times.
Right.
So we can be less reliant on these narrow launch windows.
Okay.
Or maybe we'll focus on missions that can use more flexible trajectories.
Even if it means using a bit more fuel.
It's cool to think about how those limitations will drive innovation.
Right. There are probably a lot of researchers out there who would love to just launch whenever they want.
I bet.
Regardless of these windows.
Yeah.
And maybe someday in the future,
right,
with better propulsion, we'll be able to do that.
Yeah.
But for now, we have to work within the laws of physics.
So there you have it, folks. Our deep dive into Mars launch windows. Hopefully you've learned something new about how Earth and Mars, work together and all the planning that goes into these missions.
It's a really incredible process.
Yeah, it's amazing.
And with those launch windows in 2026 and 2028 coming up, it's exciting to think about what we might find on Mars.
I can't wait.
Yeah.
Until then, keep looking up, everyone, and let your imagination soar.